Okay, so here we are again, my dear friends, and I got some posts today. Hopefully, my long waiting. There we are. I've been waiting for these batteries for so long. If you remember, a few weeks ago, I had a project about checking the Bluetooth headphones batteries, and I found a very disappointing results. And in the meantime, I ordered some of these batteries, which supposed to deliver 50 milliamps. So here is the little battery. Well, I ordered 50 milliamps, turns to come back on 40. That doesn't really bother me. It can be 40 milliamps as well. Yeah, it's looking like all are the same. So I promised myself a test for these batteries, and I'm starting with the internal resistance. And here we had 0.404 ohms. Really? Okay. Well, I don't know what to say. I never used anything like that, but for me it's looking like a huge internal resistance. Let me check another one. Same story, same kind, 40 milliamps, 0.290. Okay, maybe needs to be charged, and then we'll talk about. But as long as I'm here, let me check all of them. 0.3. Okay, so 6 little cells, 40 milliamps, 50101010. Let's check them all one by one. Yeah, I can see that they are already primed here, coated with some tin. That's nice. Okay, we got one here. Okay, 0.3 ohm. Well, 0.3, 0.3, come on, 0.4, okay, 0.34, 0.29. Yeah, so they are almost the same. And of course, nothing else to do in this situation but using my antimeter, charge soon antimeter. Let's give it a few cycles and then we'll talk. But for now, LiPo, 3 cycles, of course. Let's charge with 1C. So as long as 40 milliamps, that should be 0.0. Well, can I go on? Oh yes, of course. Look there, 0.0. It was minimum 0.05 amp. Okay, I don't want to stress the cells. And discharge with the same. Down, 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 down. 0.5. Okay, now cycling 3 times, discharge to 3 volts, charging to 4.2. Let me get this first. Okay, reverse polarity. You know something? Just let it be there. I change the polarity here. And what's nice, I can check the internal resistance too via, and always gives me almost double results. So it's almost 1 ohm. Okay, let's start the mambo jumbo. Yes, this charging with 0.05. Nice. I'm starting the time lapse. So we're gonna have a picture at each 60 seconds and or each minute, in fact, and just let it run. Okay, so here we have cell number 1 done. Let's write these numbers. Discharge 1, 25. Everything is milliamps hour. Charge 1, 28. So 28, we should have 40, and let's measure the new internal resistance. 0.005 354. Okay, let's go to number 2. Here we go, number 2. Let's check the numbers. And internal resistance 0.306. Okay, number 3, it's done also. And let's have some numbers. Internal resistance measured 4.12 with 0.311. Okay, well, that's amazing. Number 2 is just it's losing voltage or something. Interesting. Let's go to number 4 this time. Okay, so number 4, it's done. And let's have some numbers. Discharge 1, 27 milliamps, charging 27, discharge to 29 with discharging 28, 29, and final discharge with 28. Now let's measure the internal resistance and voltage. 0.238. So this is the best internal resistance so far with 4.05 volts. 0.5, I think. Yeah, that's it. Let's go with number 5. I got my first 5 little cells checked. We'll talk about this a little bit later. I got number 6 on the way now. You see, I got an idea. I have this headphones from Sony. You know, the sound of these guys, it's really, really good. I'm not using them. I don't feel comfortable in my ears. I just want to see if maybe I can fit the element inside here to these headphones. Because anyway, I will dismantle these guys to replace the battery. That's for sure. You know, the batteries inside here, they've been tested like 20 milliamps a while ago. Check the video up there. And anyway, I dismantled this for replacing the battery. And maybe I'm lucky to have the Sony headphones or elements inside those Bluetooth cases. All right, glued or simply connected by clips. Haha. Look there. I believe they are kind of bigger than what can I fit inside here. Okay, let me open it up anyway. No chance. No chance, my dear fellows. Can tell you these headphones, they have a wonderful sound. Can we compare this little itsy bitsy with these huge ones? Okay, I'm so sad. But at least let's measure the impedance or the resistance, in fact, for this kind of cells. 32 ohms. All right. Okay. Let me replace the battery at least. Okay. Let me see. Maybe I should go for number 4 and number 5. Okay, number 4. They have the lowest internal resistance, but let me check for polarity first. We should have the, yeah, plus it's here on the right. Yeah, and the other guy, yeah, it's working. I can see a blue light. That's the pairing sign or something. Okay, so this is done. I can have the band in place. We got the battery, so let's put this back in the case. But I'm so sad I couldn't feel those little Sony headphones or cells elements inside here. That could be a brilliant quality, sound quality upgrade, but maybe next time or another case. Well, is this bigger? Yeah, it's bigger. What the heck? Oh yes, of course we have this gap here. Acceptable quality Bluetooth headphones. Okay guys, so let's have a little talk about these numbers here. You see, they supposed to deliver 40 million. No way. So they are like 25% less than the advertised capacity. The internal resistance is somehow strange, 0.27, 25, going up to 0.35. And even the final voltage, it's kind of strange, you see, 4.11, 4.05, 398. Well, it's somehow close, no advice, of course. So if you consider buying replacement cells for any kind of Bluetooth devices, always buy a bigger one. If you need 40 milliamps, buy a 50. Because I see that the capacity, the true capacity, at least 25% lower than it have to be. Okay, I hope it's useful. Like always, please subscribe, like, comment, and most of all, have fun. Bye bye.